Hello everyone, welcome to Euron. My name is Kumar, guys, and today we are going to start with a very first chapter of statistics. So guys, before getting into a depth of statistics, learning all those technical things and mathematics behind the statistics, I believe we all are supposed to know a little bit of theory, a little bit of story behind the statistics, so that it will help me out to understand that why even we are going to learn statistics and what in all things I will be able to do out of this particular learning. So this is something, guys, I am going to talk about in this particular lecture, why statistics. So guys, I would like to give you one simple example. So let's suppose we are like having some sort of a fever, or maybe I am facing maybe some sort of a uneasiness on a particular day. So I'll go and visit a doctor. Now, so doctor is going to do some sort of a basic test, and then they are going to write some sort of a blood test, and then they are going to ask you that, okay, so once you will be able to get a report, so please visit me. And based on those reports, doctor are going to make a conclusive decision that, okay, so this is a kind of a medication, or this is a kind of a treatment, or this is a kind of a disease that you have. And yeah, so what will be there inside this blood test? I believe we all are aware about it. So inside a blood report, inside a blood test, obviously we are going to see a different parameter, maybe like a different vitamins labels, or maybe a different kind of analysis that doctor has written, depends upon the blood test that you are going through. Now that is going to give you a complete analysis about your body, that okay, so your body is suffering, or maybe your body is going through this particular events. Similarly, right, similarly, so let's suppose I have a huge amount of a data. For example, I have a huge amount of a sales data someone has given to me, or maybe I have accessed it through a database. But if I have to perform, if I have to understand that why we are able to do a sales, in which reason we are able to do a sales, what kind of a user are liking, what kind of a product that I'm trying to sell, or maybe what is a customer expectation, who is my potential customer, who are not my potential customer, or maybe which marketing funnel, which sales funnel is working very good for me, and which marketing funnel or sales funnel is not at all working for me. So obviously you have to run through a data. And when you are going to run through a data, right? So when you are going to run through a data, so obviously you will be doing some sort of a mathematical derivation. You are going to do some sort of a calculation, and out of those calculation, out of those mathematical derivation, which will be done by your analyst inside your company, or maybe a guy who understand little bit of statistics and a programming, you will be able to reach out to a conclusion that, okay, this is working for me and this is not working for me. So the way a blood report or any kind of a test is going to tell a detail about something which is going inside your body, in the similar manner, these statistical approach, these statistical things are going to tell me something about a data, that what is going inside a data. Because if I have a like a GB or TBs of a data, it's very difficult for me to do an analysis of a data just by looking into it. And this is where this statistical approach, this mathematical approach comes into a picture. I will say that statistics is a heart of any kind of a data. So unless and until you are not going to apply statistical concept on top of it, you will not be able to get a clear insights out of a data. And as your data grows, so obviously the importance of statistics keeps on growing. If you have a very small data, obviously you will just look into it and then you will be able to give me some sort of a conclusion. But if my data set is very big, I will not be able to give you any kind of a conclusion. And in that situation, statistics is going to give me a backup, and statistics is going to come and rescue me. This is where we are going to use statistics. Now, if I'll talk about just a data science, right? So data science is all about just a data, obviously, right? So whether we are trying to build a model, or we are trying to perform some sort of a EDA operation, or we are trying to evaluate some of the scenario. So this is going to work, this is not going to work kind of a scenario. Everywhere, statistics is going to hold my hand and it is going to guide me. It is going to show me a path that, okay, so this is what you are supposed to do, and this is what you are not supposed to do. So wherever with respect to a data I have to make a conclusion, I am supposed to know statistics. I'm supposed to apply statistics. Now, the second question in general, right? In general, I used to get from a people that is it going to be a difficult? Will I be able to learn, or will I be able to apply these statistical concept in a real life? My answer to all of you is yes. It is easy to learn. You all will be able to apply. You all will be able to convert these statistical concept into a reality, and here and there. So whenever you will play with the data, whenever you are going to build a model, you all will end up using these statistical concept. It's not very tough at all. So most of the time, or whenever you will see these statistical chapters, so most of the time you will feel like that all of these concepts I have studied maybe in my 10th, 12th, or even before that. But at that point of a time, I was learning each and everything just as a mathematics. I was not relating those things with respect to a real world scenario. And that is a kind of a mistake that we all have done, because at that point of a time, we were not aware about this kind of a domain like a data science that we are able to see, AI that we are able to see. So at that point of a time, we were trying to learn statistics. We were trying to learn those mathematical concepts just to maybe pass the exam. But those mathematical concepts, those statistical concept is having so much of relevance even in a real life. And believe me, in every domain, doesn't matter whether you are going to become a data scientist or you are going to become a chartered accountant or something else. But yes, it plays a role. It will always give you a power. It will always give you a capability to derive some sort of insights out of all the real world scenario. That's a power of a statistics, and that is a power that we are going to see. And that's the reason somewhere statistics plays a very, very crucial role for all of us. Now let me share my screen and let me write down some of the things that I would like to share with all of you with respect to statistics. So let me share my screen. I believe my screen is visible to all of you. So here, if I'm going to write that what is statistics definition wise, again, I think I have already given you a layman definition, but yeah. So if I have to write down that what is statistics, so maybe I would love to give a definition of a statistics in this way. So first of all, let me write down the chapter name. So STATS. Now this is going to be the chapter name. Now, so here, if I have to write down that what is stats. So according to me, stats is nothing but it's a science. Science of what? Science of collecting a data, organizing a data, analyzing a data, interpreting a data, and presenting a data with a meaningful insights out of the data. Just like I have given you the definition, right? That or I have given you the analogy that whenever you feel uneasy, whenever you have a fever, you go to a doctor, then doctor is going to write you some sort of a test, and then you are going to do a test, and doctor is going to make a conclusion out of those test report. They are going to start your medication out of those reports. They are going to suggest you a cure out of those reports. So obviously they look into the number. They will be able to understand that what is going inside your body. Now, in the similar manner, statistics is going to give me a power that I will be able to interpret, I will be able to analyze, I will be able to collect, I will be able to present in a way that what is going inside a data. So statistics always tells you that what is going inside a data. So let me write down a formal definition over here. So stats, so basically stats is a science which gives you a power, which gives you a power to present, collect, analyze, interpret the data with an exact insights out of the data. So this is a very, very simple definition that I would like to give to all of you, that this is something called as statistics as per me. Now, what is a core objective of the statistics basically? And especially with respect to our data science, I'm going to talk about the statistics. Again, I can talk about statistics with respect to other domain as well, but here, so I don't want to talk about this statistical concept with respect to something else. But yeah, so we'll try to focus more and more everything inside a statistics with respect to a data science. It itself is a very, very big domain. It's a very big field that you will be able to find out. So here, if I'm going to talk about that, what is a core objective? Core objective of statistics, because before even learning this statistics, you are supposed to understand that what I'm going to perform, what kind of a benefit I will be able to get if I'm going to learn statistics or if I'm going to implement statistics. So here, the very first core benefit that you all will be able to get, that you can summarize or analyze huge amount of data. And that's true, right? So obviously it is going to work with a small amount of data, but the real problem happens, or you will be able to see a real problem when your data size is very, very big. And the second part is you will be able to understand a pattern. You will be able to understand a relationship inside the data. So it will give you a power. It will give you a power to understand relation between a data. Now, third core objective, it is going to give you a power to make a decision out of uncertainty. So if you are not certain about some of the decision that you would like to take, so obviously statistics is a way. It is going to show you a path. It is going to behave like a light of hope for all of you. So where it is going to give you a capability. So where you will go and you will be able to make a decision. So it gives you a power. It gives you a power to make decision after looking into a data. So this is going to be the fundamental objective that you will be able to find out if you are going to learn statistics, and exact same thing you will be able to apply even with respect to a data science or maybe with respect to any other domain. Because at the end of the day, as a data scientist, as an AI guy, you have to deal with a data. So this is where your day is going to start, and with data, your day is going to end. And statistics will come all the time in between, not as a mathematical concept or not as a mathematical calculation all the time, but yeah, in a different form. Statistics will come into a picture, and then it is going to rescue you. It is going to give you all such kind of wonderful insights and a power, so that ultimately you will be able to do some sort of a decision. Now, so if I'll talk about a data science, so in general, right, because as of now, we are not very much aware about use cases of a data science. As of now, we are not even aware about like a lot of scenarios inside a data science or even inside a statistics. So as of now, as a 0th day, as we all are going to start a statistics, so I would like to talk about some of the use cases which we all will be able to understand, at least theoretically, right? At least theoretically. So use case of this statistics, I would like to talk about. So just a couple of use cases, because there are like millions of use cases you all will be able to find out everywhere. But as I said, that this is my day 0 in statistics. So obviously I'll try to give you a use cases based on this day 0 philosophy. So whenever inside a data science, so you have to basically perform some sort of a EDA operation. So EDA operation. And what is this EDA operation, by the way? So EDA operation, nothing but it's called as exploratory data analysis. So where you are going to apply statistical concept, you will be able to find out a mean, median, mode, standard deviation, and many more things out of the data, and then you are going to make some sort of a conclusion. So obviously when we talk about a mean, median, mode, standard deviation, all such kind of things inside statistics or inside a data science, we are talking about mathematics, we are talking about the statistics. So this is a one places where statistics comes into a picture. Now a feature selection. Feature selection. So let's suppose I have a data set given to me, and where I have a multiple columns, a lot of columns I have, so on. So till xn I have a column. Now which column is important, which column is not important, which data set is important, which data set is not important, which is contributing, which is not contributing. So obviously who is going to tell me? There must be some sort of a mathematical, like a derivation, if I can do out of this entire data set, if I will be able to establish some sort of a mathematical relation out of this data set. So maybe I will be able to make a decision that, okay, so let's suppose if I have hundreds of columns, maybe thousands of columns, so which column I'm supposed to choose, which column is going to give me something which I'm looking for inside a data set. And again, this is where statistics comes into a picture, and this approach is called as feature selection. So feature selection is nothing but selecting a input or selecting the column that you have inside your data set, or input, or I can say all this X you are going to select, you are going to find out a relationship between a Y. In case of a supervised, again, I'll be talking about supervised, I will be talking about all of these things going forward. But yeah, so again, this is the place where day to day you are going to use statistics, and out of the statistics you are going to take a decision. Then we try to make a lot of models. So when we are talking about a data science, so obviously we are going to build not just one or two, but a multiple models. Now whenever you are going to build a model, obviously you are supposed to evaluate those models, right? Because data science, obviously what you will do as a data scientist, so you are going to build a lot of model, maybe a machine learning model, maybe a deep learning model, maybe a computer vision model, maybe a NLP based model you are going to build. Now once you are going to build all of those models, you are supposed to even evaluate those models. Unless and until you are not going to evaluate it, you can't send your model to a production. And even at that point of a time, a different statistical technique will come into a picture, which is going to give you a power, which is going to give you a capability to evaluate different kind of a model. Again, there is no one thumb rule that, okay, apply this model evaluation on everything. No, that is not going to work. That is not going to happen. So whenever we are talking about a model evaluation, we are talking about a different approach for a different category of the model, or for a different kind of a task. And everywhere a different kind of a statistical theory or concept comes in between. And out of that, you are going to evaluate. You are going to say that how good or bad your model is. So model evaluation as a data scientist, again, whatever use cases which I'm trying to talk about over here. So I'm talking about all of these use cases in terms of basically a data science. Again, so a lot of time what we do is, so we try to build a predictive modeling, right? So where we try to do a probability distribution, we try to implement a sampling theory. Again, at that point of a time, statistics is going to come into a picture. So there are tons of use cases you will be able to find out, guys. And like I said, don't try to understand everything on day zero. We have a time. We are going to explain, or we are going to explore each and every topic one by one. And as we are going to progress inside this particular segment, you will be able to understand things in a better and better way as your day is going to pass with statistics. Yeah. So this is the use cases in general. This is the day zero use cases which I would like to give you. Now, when we talk about statistics, so again, people have divided this entire statistics into a couple of parts. Now, from a 10,000 feet, if I look into the statistics, so I can try to divide this statistical concept or this entire statistics into two major parts. So I can try to divide this stats into two major parts. Now, what are those two major parts? So the very first part is going to be a descriptive statistics. Descriptive statistics. And the second major part in which I can try to divide this entire statistics is called as inferential. Inferential statistics. Now, so what is the difference between this descriptive and inferential statistics? So on day 0, if I have to give an example, and with the help of example, if I have to explain you that what is the difference between this descriptive and inferential statistics, so maybe I would like to take some sort of an example. So if we are talking about a descriptive statistics, which is this particular part, so in general, right, in general, so we try to find out some of the, or we try to follow the approach, so where some of these mathematical concepts, some of this statistical concept talk about some sort of a description of a data. This is what this descriptive means. Now, when I say description or some of these mathematical concepts to describe something about a data. Now, what are those things basically? What kind of a description we are looking for? What kind of a, details that we are looking for? What kind of a summary that we are looking for? So in general, so whenever we are going to apply something like a mean, which is obviously in the average, median, mode, or we are going to apply maybe a range, maybe a variances, maybe a standard deviation, or maybe a histogram, pie chart, or maybe a frequency distribution. So all of these things are going to tell me or is going to describe something about a data set. Now, all of these things comes inside our descriptive statistics. So again here, so if you are going to find out a mean, median, mode, standard deviation, variance, maybe a histogram, pie chart if you are going to draw, or maybe a frequency distribution if you are going to do with respect to a data, then that kind of a approach, because all of these things, when I say I'm going to apply a mean, median, mode, standard deviation, variance, or maybe histogram, or maybe a frequency distribution, or pie chart, or any other kind of a distribution chart, frequency distribution chart, I'm simply trying to say that I'm trying to get some sort of a description or some sort of a summary out of the data set. So wherever I'm going to apply all of these mathematical things to get some sort of a summary out of this data, now that kind of a statistics is called as descriptive statistics. For example, let's suppose if I have given you a salary sheet. Now in that salary sheet, so basically, it's a salary sheet of XYZ organization. And let's suppose if I have given you a salary sheet. Now, in that salary sheet, obviously person name will be mentioned. Apart from that, so person age will be mentioned, join date will be mentioned, a monthly salary or CTC will be mentioned over here. And then rest of the information will be mentioned inside that particular sheet. Now, let's suppose inside this particular sheet, so we have maybe 100K or maybe 100,000 of record which is available. Now, if I'm going to ask you a question that can you please tell me what is the average salary of the entire organization? So what you are going to do? So obviously you are going to perform a mean operation. Those who don't understand what is a mean, don't worry about it. It's a part of your chapter. So we are going to anyhow talk about it. Let's not talk about mean as of now. Let's not take a word called as mean. So let's talk about average, right? So if I'm going to ask you a question that what is the average salary of the entire organization, you will be able to give. Now, inside an organization, there will be a multiple department. There will be a marketing department. There will be a sales department. There will be a tech department. There will be a C-suite, right? There will be an operation department. Again, depends upon the domain, depends upon the company. So there will be a different department. So now if I'm going to ask you a question that which department is costing more to a company, you will be able to find out, right? You will be able to find out easily. Now, if I'm going to ask you a question that can you please give me the average age of a person in a particular department, or average age or average time spent with the company, right? You will be able to give me all of these detail. You will be able to give me all of these summaries out of this mean, median, mode, standard deviation, variances, you will be able to do some sort of a chart plotting, and then you will be able to show me some more information, some more in-depth information. Now, this is where this descriptive statistics comes into a picture. So where it is going to give you a summary, it is going to give you some sort of a description about a data set which is available inside my file. So hope all of you are able to understand that what kind of a statistics we are talking about with respect to a descriptive statistics. Now, so now let's come to a next part. So what is the next part? Inferential statistics. Now, what is the meaning of this inferential statistics, by the way, right? What is the meaning? So just try to focus on this word called as inference. Now, what is the meaning of inference, by the way? So inferencing is nothing but prediction. Yeah. So doing some sort of a prediction out of the data, finding some sort of a probability out of the data. This is the meaning of inference. Now, guys, so I never ask anyone to remember any of these terms, because you shouldn't just know about it, right? You should just know about it. You should just read about it and then leave it. You are not supposed to mug up any of these concepts, because when you will try to focus on a word, right? So word itself, in majority of cases, I'm not saying in 100% cases, but yeah, in majority of cases, a particular word itself is going to give you a complete detail about the particular situation. So here, when I'm talking about an inferential statistics, so basically I'm talking about a kind of a statistics which is going to help me out in terms of doing some sort of a prediction, or maybe like some sort of a inferencing, some sort of a probability. It will help me out in terms of finding out from the data set. This is where inferential statistics comes into a picture. Now, when we talk about inferential statistics, so we try to talk about basically a hypothesis. So hypothesis, hypothesis testing. Now, there are a different kind of a hypothesis testing that we are going to talk about. If you will follow along with the syllabus, you will be able to find out a tons of topic inside that, which I have already included, and I'm going to discuss one by one with a beautiful example, and sometime even with the Python code sometime. Again, so when we talk about inferential statistics, so we talk about hypothesis testing over here. We talk about basically a confidence interval, by the way. We talk about basically a regression analysis, we talk about basically a test called as t-test, z-test, and then ANOVA kind of a test. Again, there are multiple different kind of a test that we are going to learn. We are going to even do it on top of the data set. But yeah, so what is a meaning of a inferential statistics? A kind of a statistics which will help me out in terms of predicting something. And this is where inferential statistics came into a picture. Now, if I have to give you an example, right, that what is the example by which you will be able to understand little bit about inferential statistics. So let's suppose, so if I have collected a sample of 100 customer, right? So if I'm going to select a sample of 100 customer, or maybe 100 student data, if I'm going to collect from my platform. So if I would like to know that how many students are learning, how many students are not learning, how many students will be able to crack a job in next 2 months, maybe in next 6 months, and maybe in next 1 year, I have to create a different kind of a bucket. Now, all of these places, inferential statistics will come into a picture, and it is going to help me out in terms of doing a different kind of a test, a different kind of a hypothesis, different kind of assumptions. And based on that, I will be able to make a conclusion that in a coming month, how many students we all are going to see get placed into a particular company. So this is one of the example. Again, like I said, so there will be a tons of example which we are going to run through going forward when we are going to talk about statistical concept in a detailed way. Now, so the next concept, so we are able to divide the statistics into two parts. So one is a descriptive statistics, one is the inferential statistics. Now, so whenever we talk about a statistics, so always we talk about a data, right? But again, so we can try to divide this entire statistical concept in two parts based on the kind of a data that we are going to acquire. So here there is a concept called as population versus sample. So here POPULATION. population versus sample. Now, what is the meaning of population versus sample, and why we are even talking about it? Are not we supposed to apply the entire mathematical concept on the entire data set which we were looking for? Yes, obviously we are supposed to do that, and that's a best case scenario. But in majority of the cases, right, in majority of the cases, you will not be having an access of the entire data set, or there is the entire data set is called as population. For example, so if government of India, right, or any government in this entire world would like to, right, would like to run a scheme, maybe for underprivileged people, so it's very difficult, right, it's very difficult to find out that in which state or in which city or maybe in a which district, what is the number of or exact number of underprivileged people based on some sort of a income criteria are available. So whenever government is supposed to do a budgeting, whenever government is supposed to make a decision, so what they will do, so they will try to maybe run through a small survey where they're like a agents, or you can say they're like a agency people will go and they will try to collect a data from a sample, maybe from a 5 district, maybe from a 5 state, maybe from a 10 state. They are going to collect all those information, all of those data, and then based on that they are going to make a conclusion, they are going to make a decision that okay, so this should be the budget, and this budget should go to this particular state or this particular district or this particular city or this particular set of the people, basically. So every time, what I'm trying to make over here as a point is that every time it's not possible to access a whole data, whatever data or whatever use cases on which you are working. So sometime, or not sometime, I would say majority of the time, right, majority of the time, so we are supposed to go through a small amount of a data, a subset of a data, and based on that we are supposed to make a conclusion. And this is where the concept of population and sample comes into a picture. So if I'm able to access the whole data for a particular use cases, then that data set is called as basically a population data. If I'm not able to access, if I'm able to access maybe a subset of the data, then in that situation it's called as sample. And majority of time we all will be dealing with a sample of a data. Whenever, even as a data scientist, whenever you will try to do some sort of a data analysis on top of the real-time client data, so it's not like client is going to give you all the data since years on years that they have accumulated or they have generated. No, not at all. So they are basically going to give you a sample of the data, maybe like 1,000 record, maybe 1 million record max to max they are going to give you, and 1 million is a very big number, by the way. So they are going to give you this much of data, and they're going to ask you that okay, so run your like a statistical concept on top of it, maybe just run your analysis on top of it, and then give me the conclusion, give me the result, basically. And yeah, so that is basically a sample of the data, and you are going to take a decision based on that. But again, so when we talk about a sample of the data, so there are a different criteria by which we are going to build a sample of the data. It should not be a biased one, because if we have access of whole data, then it's completely fine. It's a true data that I will be able to get. But when we are talking about a sample of the data, it should not be a biased one. It should not be the fabricated one. It should not going to be a deviating one, right? So that, because if my data set is corrupt, if there is some kind of a disturbance inside a sample, if sample data set is not at all a true data set, which I can believe, so obviously the statistical analysis that you are going to run is not going to be a true analysis. And this is where, right, this is the place, or this is where, so we always try to apply a different kind of a technique in terms of acquiring a sample of a data. Again, those techniques we are going to understand, those techniques we are going to learn inside our chapters. But yeah, so there are like a pros and cons that you will be able to find out with respect to a sample of the data and the population. So whenever we talk about a sample of the data, so it's going to be a cost effective, by the way. So you don't have to go out and then collect all the populations of the data, and it is going to like save your time, it is going to save your energy. And it is, if you have a true sample of the data, so you can just try to enfold it, or you can try to replicate it, or you can try to think that okay, so if this is the statistical analysis of this sample, then this is going to be the statistical analysis for the whole population. So without even looking into the whole data set, right, So without even looking into the whole data set, you will be able to make a conclusion over here. Simple, right? Now, so population data, simple. So like population data is going to be anyhow a true data set. But when we talk about a sample of the data, so there are multiple approach, there are multiple way by which we try to collect a sample of the data, or there are multiple different kind of a technique that you all will be able to find out. So one of couple of technique, let me write it down. So there is a technique called as simple random sampling. I believe just by name itself, you all are able to understand. Simple random sampling. Now, the second technique could be stratified sampling. The third kind of approach is called as cluster sampling. Cluster. And the fourth kind of approach is called as systematic sampling. Sampling. So these are just a couple of approach I have written over here. So again, these are not the end game, I would say. These are not the only one or only approach that we used to follow. And as we go deeper and deeper, so obviously we'll try to explore all of these approach, and we are going to build a use cases based on those things. So here I believe guys, you all are able to understand what is the difference between population and a sample. And again, so whenever we are going to deal with all of these data, as we are talking about a data collection, as we are talking about the data science. So obviously inside a data science, majority of the times, at least nowadays, you all will be able to find out a unstructured data as compared to a structured data. So let's talk about this a little bit. So unstructured data. Unstructured data versus structured data. I would love to explain you this one just with the help of a couple of examples, and I believe you all will be able to understand. So when we are talking about guys unstructured data, right? So what is the what kind of a data is called as basically unstructured data? So social media post, social media post. So whenever we are trying to write like some sort of a post, we are trying to put some sort of a smiley, or we are trying to add some sort of a gify as a reply, as a comment, or whenever I'm trying to do a fresh post. So again, we never care about basically what we are posting, whether we are posting images, maybe we are posting a ad gify over there, maybe we are posting some sort of a audio, maybe we are trying to post some sort of a video. So we can go over there and we can try to post any kind of a information over there, any kind of a paragraph over there, and this kind of a data is technically called as unstructured data. So in general, there is like a tons of data set which is available on a social media like a Facebook, Instagram, Twitter, Facebook, YouTube, everywhere, and on all of these platforms. So we are actually dealing with unstructured data, and majorly this unstructured kind of a data is been used, right? So this is been used inside NLP, or maybe in terms of solving some sort of a sentiment analysis kind of a problem, or there are some similar kind of a problem which exists inside the data science industry. And this is where we are going to use this unstructured kind of a data. But again, so yes, we do run a lot of statistical operations. We do run a lot of mathematical operations on top of this unstructured data as well. Now, so whenever you are going to mail to someone, or whenever you are going to give a customer review, right? So again, your mails, customer review, or maybe audio, video, gify kind of a data is basically called as unstructured kind of a data. Now, what is the meaning of this structured data, by the way? So a simple example I would like to give you. I think you all have seen an Excel sheet, right? In Excel sheet, there will be a column name, and inside this respective column, so we try to fill all those information as per the column headings or as per the column name which is given to us. Now that kind of a data is basically called as structured data. Or you must have heard about a SQL system, or maybe a RDBMS system, relational database management system. So where we try to create first of all columns, right? So we try to create first of all what? We try to create first of all columns, and in a respective column. So we try to store all of those data, right, in a respective column. And we try to perform read, write, update, delete, all those kind of operations. So this kind of a data is basically called as structured data. So whenever we are talking about some sort of a industrial system, for example, maybe a CRM system, maybe FIFO system, or HRM system, SCM system, right? So where we have designed a system in such a way that we are going to store all of these data into a tabular format inside our data set, or maybe we are going to get some sort of a data in a form of Excel sheet, and that kind of a data is called as structured data. Even banking example, if I have to give you, right? So whenever you are going to log in into your bank account, so you will be able to see a tabular format. Inside a tabular format, you will be able to see your account number, and then debit, and then credit, and the remaining amount or balance, each and everything, right? So that is a kind of a data which is getting populated from the structured table, and that kind of a data is basically called as structured data. So simple meaning of a structured data is, so wherever we have a schema means wherever we have a column names, and as per the column names in a tabular format, we are trying to store a data that is called as basically structured data. But so nowadays, majority of data, almost 80%, 90% of the data, you will 80%, 90% of the time, you will be dealing with unstructured data. So even you should know that how to apply the statistical concept on top of not just a structured data, because that is pretty much defined. We can do it very, very easily, but how we are going to apply some sort of a statistical concept on top of unstructured data, how we can try to derive some sort of insights out of this unstructured data. And even this part we are going to explore as we are going to move into our lectures. So hope guys, you all are able to understand a little bit about something that we are going to discuss, a chapter that we are going to cover, or the things that we are going to learn inside this whole statistics. Now, the syllabus is very, very big, no doubt about it. I have not left any topic which is required for you inside a data science domain, whether it's a machine learning, deep learning, or maybe a NLP, or maybe a generative AI. So I'm not leaving any topic which is required and which I'm not discussing over here. So everything I'm going to discuss in very detail, in very depth to all of you. So, and so that we'll make sure that you all are going to get advantage of it. You all are going to learn in a better way. And for a lifetime, you all will be able to apply the same concept even in your day-to-day life when you are going to solve some sort of a real-time problem. Now, that's the intention behind this particular series that I have started. So hope all of you are going to enjoy this series going forward. All of you are going to learn a lot. And even in this particular lecture, so you have learned or you have gained some sort of insights out of this entire lecture. So with that, guys, thank you so much. See you again in my next lecture. Till then, take care, everyone.